Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 8, 2025, just yesterday. The standout claim is a training-free method that boosts visual reasoning by contrasting attention maps, with improvements reported up to 75% on open-source models. The paper is titled, Focusing by Contrastive Attention, Enhancing VLMs Visual Reasoning, and as we'll see later, the implications for practical deployment are quite significant. In short, the work links visual complexity to dispersed attention, explains why that hurts accuracy, and introduces a pixel-level contrastive attention trick that isolates task-relevant signals without extra training or external tools. Alright, Figure 1 shows that hiding background clutter steadily boosts the probability of the correct answer token, because attention stops drifting to distracting regions. Progressive masking means covering more of the image step by step while keeping likely task regions visible. The left plot tracks star versus circle, and the right plot tracks 8 versus 0 as masking increases. The image strips illustrate how crops tighten around the relevant areas as the mask ratio grows. So, Figure 2 illustrates how attention sharpens with depth, but stays scattered in busy scenes, which explains why answers go wrong. Attention entropy means how spread out the model's focus is, like a flashlight beam that widens in clutter. The top row converges cleanly onto the jersey number, while the bottle shelves in the lower rows keep multiple hotspots, signaling confusion. The columns track shallow, middle, and deep layers, and the shift from global scanning to focused convergence stalls when textures and colors are dense. So Figure 5 makes the key point that dispersed attention goes hand in hand with worse answers, and that focus tightens as layers go deeper. The left panel links higher attention entropy to lower accuracy, which means a scattered focus hurts reasoning. The right panel tracks entropy by layer and shows a steady drop with depth, alongside wider confidence bands. Those widening bands mean some images become sharply focused while others stay noisy, so outcomes diverge. So Table 1 shows that contrastive attention refinement boosts accuracy across models and datasets, with the strongest jumps on the more challenging benchmarks. The method compares attention from a general prompt and the task question, then re-infers on cropped regions, which reduces visual noise by focusing on high-score areas. The time step choice matters because later tokens carry fuller context, and 10 typically wins. One striking result is the very large relative gains on the V-star benchmark for smaller models. Okay, 2 takeaways stand out. First, visual complexity scatters attention and hurts answers. And second, a simple contrast between general and task prompts lets models isolate semantic regions and recover accuracy, training-free. The broader implication is practical, deployable focus without extra data or tools. That is it for the AI Research Roundup. I am Alex. Thanks for listening.